Hello, and welcome to the Soils and Engineering Laboratory at the Department of Geology and Environmental Science, James Madison University. Today, we will demonstrate on how to use the direct shear device to determine the angle of internal friction and cohesion of both a sandy and a clay soil. The instrument we will use today is the Humboldt 2750 series shear tester, which also has the capacity to test for consolidation, which we will not use in the rest of this video. Weigh out 500 grams of dry mill rock sandy soil and also 500 grams of Frederick clay-rich soil provided using the large scale that can accept larger masses. Do not use the smaller scales as you may damage them. Power up this balance by pressing the button as shown with your hand out and wait for several minutes for the instrument to self-calibrate. After this calibration is over, place an empty beaker or other vessel on the scale and zero that out. It should now be close to zero with some variability due to the airflow from above. Continue to fill your vessel until you have reached roughly 500 grams of soil. Shown before you here is the apparatus that you will need to put together your shear experiment. First of all, we have the shear box that is shown on the far side. That's the bottom half of the shear box. And there is the top half of the shear box with the arm and two spacing screws that we'll look at shortly. We also have our two shear bolts shown with the red heads. We have the top, and we have the compactor along with several tools that we'll use at some point. We first of all want to add enough water to our sample to ensure we have optimum moisture. For this sample, for the mill rock series, we determined we needed 70 milliliters of water to the 500 grams of soil. Take the frosting knife and thoroughly stir the sample until we have uniform water throughout the sample. Take your time as you do this because you want your water thoroughly distributed through your 500 grams of soil. Next, we want to reassemble the shear chamber. You'll notice the thumb screws with the black heads on them, and we want to retract those thumb screws such that the tips are withdrawn so they are not in contact with the lower half of the shear box. Now take the shear bolts with the red heads and place them in, turn clockwise, and tighten them until they're snug. We now want to take our sample of soil, and we're going to add 3 to 4 different layers, or what we refer to as lifts, into the shear box. Here's the first lift. We want to fill this about 1/4 to 1/3 of the way through. Take your tool and spread that soil out evenly so it's more or less uniform thickness at the base of the shear box. Now take the compactor, apply your force of your weight as best you can straight down vertically. Withdraw the compactor and add a second lift. Compact again with your full body force. And there is our third compaction. Inspect the shear chamber to see if you are close to the surface within a few millimeters. Sometimes these shear boxes will have open holes on either side of the chamber indicating roughly where you should be. Now take the cap, and you'll notice there's fins on those caps, and you want those fins perpendicular to the direction of shear, and place that in there snugly. Next, transport your shear box over to the direct shear device. We want to now ensure that our cradle there is between the two blue strips of tape. If not, reposition that cradle box so it is between those two markers. We want to loosen the far side two nuts. Be sure that the collar is loose, and then our shear box should be able to slide beneath the collar and link into the arms that go back to two wing nuts off in the distance. Once your shear box is inside the cradle, you can go through and retighten those two silver nuts and tighten the lateral screws so they are fairly snug. And now we're going to reattach the collar so it is snug. We want to be sure that we don't over-tighten any part of this shear box assembly, because we want the machine doing the shearing and not our own actions. Next, we are going to release the weights mechanism. And now we should be ready, double checking everything. And again, you want to take your time with this. Now we're going to remove the shear bolts. This is frequently, at times, forgotten, and you'll only do it once in your life, hopefully, if you do forget. Oh, the shear bolt got loose on us. So we take out the shear bolts, put them back into place, out of the way for future use. And now, once those shear bolts are removed, we're going to now tighten those black-headed spacing screws. So we slightly lift the top shear plate from the bottom shear plate, and you'll feel them actually touch as you continue to screw them clockwise as you tighten them down. And after a couple of runs of this, you'll get the hang of it. We then turn our unit on, and I think we're ready to go. We now want to put the prescribed weight on here. This unit has units of tons per square foot, and the first unit of weight we'll put on is 1/8. 1/8 ton per square foot. We make sure that the weight assembly is free to swing, that there's nothing there to impede it. There is an arm for this. And now we're going to zero out our values, tear them out so we can start fresh for this next experiment. So here's the apparatus up close for the data that you'll be collecting. You're going to first of all want to zero out F1, F2, and F3, which are the load, which is your shear stress in units of pounds. That's the lateral pull. Second line is your horizontal displacement of the instrument. And the third line is a vertical displacement, which we're not going to worry about in this experiment. But you'll push F1 twice, as well as for the same for F2 and F3. This experiment's actually on the move right now. You've already pressed the upper right-hand key, the arrow, and that engages the system. And you will continue the test until your load number doesn't change. Here it's 4.7, It essentially has reached its maximum. That's your value. You'll report. After you made your final measurement and record your value of shear stress in units of pounds, go ahead and turn off the unit by hitting the stop button. Now you want to stabilize the weight so the load is taken off the sample. And now we're going to loosen all the different knobs, starting with the screw knob for the collar. We're going to loosen the two end nuts for the load assembly, and then we'll take away those horizontal screw nuts as well, with the goal to remove the shear box carefully. Once we have enough slack provided, we pull the top part of the shear box out, which has been separated from the bottom, as you can see here, as a result of the shear stress test being executed. Return your shear box back to your working surface for reassembly. First, take the top plate off and begin to remove the soil from the upper part of the shear box, taking your time. The goal is to clean off all surfaces as thoroughly as possible, so when you have your second run, there's a minimal amount of friction between your shear box side surfaces and your compacting device. Do the same procedure with the lower part of the shear box. Once you've done cleaning the lower and upper parts of the shear box, return the set screws back to a distance so that they will not be touching the lower part of the shear box when you reassemble it. Double check that all surfaces are clear of soil. Go ahead now and reinstall your shear bolts, turning those in a clockwise fashion. If the screws do not set initially, back them out a quarter turn counterclockwise and re-engage. If you still have trouble, trade them out. Clean off your top surface as well as your plunging tool, again to minimize friction between the sidewalls and soil. Reorganize your set of tools, and now you are ready to begin part 2 of your next run. Return the old soil to the recycling bin. And that concludes our test for the direct shear device from our laboratories at James Madison University, Department of Geology and Environmental Science. Thanks for listening.